Okay, so good day, guys. Okay, so this will be our next topic. So last time we have already discussed the moment distribution method for beams. Okay, so today we'll be discussing about the frames. No? So do not worry because the concept is similar. No? So maybe there are just some changes with respect to the vertical members that we have. Okay, because we all know that in beams we all the members there is in horizontal, no? So let us try to discuss MDM in frames. Okay, so given this example, guys, so we are tasked to analyze the frame in the figure by moment distribution. Okay, so take note, E is constant, so this will be our frame. So you have this AB here now with 2I. Then the rest of the members are I lang na. So I lang na siya. Then we have this load here sa AB 3.6 keep per pit. Then we have this 32 keep sa BC. Okay? So ang sa A, guys, we have this hinge support, then we have this ruler support. So again, from the concept that we have discussed from beams, no, so any member that has a ruler or hinge support at the farthest end, so the stiffness of that member should be modified. Okay, so we will expect that AB, this member AB will be modified, no, due to this outermost support that is a hinge, and also expect that this DC here will be modified as well, no, since the support at D is a ruler support. Then sa F is a fixed support, then E is a fixed support. So we don't have any problems about that. So also expect, guys, that moment here, not A and D is 0. No? Kay, because simple supports will not induce moments. Okay? So first is to compute the distribution factors at B. No? So we don't have any worry about the distribution factor at A. No? So we expect that DF here is 1. No? 1. Then also here sa D, 1. Then E and F is 0. No? So DF, since that is a fixed support. So our concern now is at joint B and joint C. Okay, so in order for us to compute the distribution factor at B, so we have to get the stiffnesses, no? Stiffnesses of AB, BF, and BC. Okay. So for AB, so here we go. So we have this modification factor here, which is the 3 over 4, then times 2I over the length 20. So we have this for AB, 3I over 40. For BC, so I over 20. Then BF is I over 10. Okay, so that is with respect to the length. And submission of all these three stiffness here. So we have 9I over 40. So to get DF, so DFBA is equal to KAB over summation of K, so equal to 0.33. So next for DFBC, so KBC over summation of K 0.22, and for DFBF is equal to 0.45. And all of these BF should be equal to 1. Okay. So that is for joint B. How about for joint C? So for joint C, we have this for CB. No? For joint C, guys, we are tasked to determine the stiffness at CB, CE, and CD. And we will expect that the DC, no, or CD will be modified. Okay, for CB, so I over 20. Then for CD, 3 over 4. Okay, so this is the modification. So I over 9. And KCE is equal to I over 10. And if we sum up all the stiffnesses at C, so we have 14I over 60. So this will be our results, guys, for our DFs at joint C. So this must be equal to 1. All of this, if we sum up all this DF here. Okay, so that is for DF. Then how about for the fixed end moments, So, ang naalay fixed end moments, guys, is the spans A, B, and BC because those are the only spans that were loaded. Okay, so for AB, that is uniformly distributed load. So we have this formula here, for FEM. So negative 3.6 20 squared over 12. Then that is negative. Then positive at BA. Then for BC, negative PL over 8 because that is the concentrated load at the center span. So we have this negative 80. Then for CB, positive 80. Okay, so those are the DFs and EF, guys. So we'll proceed to our solution. So the Excel file. Okay, so again, I made an Excel file for it, for us to have an easy solution. Okay. So remember, this is the frame. Okay, so again, the solution is quite complicated, guys. So you have to arrange it accordingly. Okay. So expect that you will have this for AB. So you should have this distributions here. Now for AB. Next for BC. So this for BC. Then for the vertical members for BF. Okay, so you have this here. Okay, so BF. Then for CD. For CD. So you have this here. Okay, for CD. And for CE. So you have this distribution here. So again, the same with what we have done last time. So first, we will put the distribution factor here. This is a distribution factor for A. Okay, so this is for A, negative 1. Then this is for BA, negative 33. So these are the results from the solutions PowerPoint, guys, earlier. Then this is for BC. Okay, so this is for BC. Then for BF, so you have this here, negative 0.45. Okay, that is at joint B. How about for joint C? So for joint C, guys, this is for CB. Okay, so take note, this is for CB. So negative 0.21. So this is for CD. Okay, so negative 0.36. And this is for CE, negative 0.43. For other joints, so at D, so this is negative 1, DF, since that is a ruler support. Then for E, so 0, and also for F, 0. Okay, so that is the value for DFs. So next, after DF, then we will be having these fixed end moments here. So this is for AB, negative 120. Then for BA, positive 120. So this is for BC, negative 80. For CB, 80. And the rest will be 0. Okay, so since the member is not loaded, or the segment is not being loaded. So 0, 0, 0. For CE, 0 as well. For BF, 0 also. Okay, so 0. FEM. Okay, so joints B and C will be the critical joints here. So the same with what we have learned from the beams. So B and C should have a 0. Should have a 0. Should have a 0 unbalanced moment later. Okay, so we'll do the cycle, guys. So you have DF and EF already. So first for first for AB. Okay, so for AB guys, again DEM is FEM times negative of DF. Okay, so we'll have this 120 here. Then how about for this, no, for BA? So BA, so how did you get negative 13.2? So negative 13.2 is the sum or the algebraic sum of the FEM of BA, which is 120. Then the FEM of BC, negative 80. Then plus 0, no? So FEM of BF. Then times the modification factor. So now this is the only difference, guys, no? So since you have these three members connected at B, so the three FEMs should also be considered. Okay, so negative 13.2. The same with negative 8.8. So we get this from atong FEM sa BA, FEM BC, and FEM of BF, then times the modification factor of BC. So negative 0.22. Okay. Then for this, for BF, FEM for BF, so negative 18 again is from that values. Okay. So FEM of all those connected members, then times the distribution factor, which is negative 0.45. Okay. So that is at joint B, no? How about at joint C? Okay, joint C, so this is from the FEM of CB, so it is 80, FEM of CD, which is 0, and FEM of CE, which is also 0. Okay, then times the modification factor, negative 0.21. So that is for CB, guys. How about for CD? Okay, so you should really arrange it accordingly, guys, no? For you to not confused with the arrangements. Okay, so this is DM. So this is only for the first cycle. Okay, so how about this negative 34.4? So again, all FEMs of CB, CD, and CE, then times the modification factor, which is negative 0.43. Okay, so that is for joint C. So for joint D, so we don't have problem here, no, for joint D, because this is 0, no, don't have a load. So that is loading FEM times the negative of DF, so 0 gapon na, guys. Then for E, 0 gapon, no, so we don't have the load here, so 0, so 0 gapon ang DM nila, guys, no. Then also with F, so 0. Okay, so in order to complete the first cycle, so we have to get the COM, no, the carryover moment. Okay, so again, at A, so this will be locked, no? So you notice here that we have this double line here, no, color blue. So we will lock this since we have already modified AB. Okay, so we modified AB. So if we lock this here, so this will not get a 1/2, no, 1/2 carryover moment from the partner BA. Okay, so you will not allow to carry over, no, at A. But take note, AB, this 120 DM here should be passed, no, at BA. Okay, so dapat ma-carry over siya dito, guys, sa BA. So siya muhatag siya, no, muhatag pa siya. Matag siya 1/2 dito kay BA, pero siya dili na siya modawat og 1/2 kay BA. Okay? So take note of that. So si 120 pasa dito 1/2, no, ang COM na to complete the first cycle. Then the same with BC. BC, guys, is pasanay na sila. Okay? So pasanay na. So pagpasa ni mo na dito, negative 16.8 divided by 2. So we have this negative 8.4. Then negative 8.8. Then pasa dito, negative 4.4. So that is the first cycle. No? Next for CD. No? For CD guys, the same with this. No? So you notice here that we have this double line. So ato siyang gilak since ato nang gi-modify ang stiffness nga ganina. So ato siya ilak pero ipasa na to na dito. Okay, so pasa. So 0 lang gihapon na siya. Then how about for CE? So for CE guys, so si negative 34.4 pasa dito 1/2. Okay? So negative 17.2, then this 0, so pasa ka dito sa 0. Okay, for CE. Then lastly for BF, so negative 18 pasa dali. So you have this negative 9, then you have this 0 here. Okay? So pasa dito. Okay, so that is the first cycle. So again, we will evaluate if there is still an unbalanced moment. No? So we have this 60, negative 8.4, then 0 here. No? So for sure, we still have unbalanced moment. No? Kung ato ni at 60 minus 8.4, so napa dyan na difference guys. So I think negative 51. No? I think 51.6. Then for C, or napa dyan guys, no? Negative 4.4, 0 o 0. So sa C, murag gamay ra ang balance moment dala guys, no? So negative 0.4, negative 4.4. Okay, so we still have to do another cycle. Okay, so for the second cycle, we get a DM again distribution, no? Distributed end moments. So this is 0 already, no? Kaya 0 na siya. So imaginary na siya na 0 guys, no? For us to have this 0 here, no? Para makita na to ang distribution. So again, we are concerned with B, no? DM. Okay, so ginsa na po nato ng negative 17.028. So same lang gyapon guys with the first cycle, no? So COM, no? COM na karon, COM of BA, COM of BC, and COM of BF, then times the distribution factor. Okay, the same with this. Okay, so 60 plus negative 8.4 plus 0, then times na to sa distribution factor, which is negative 0.22. Okay, then how about this, no? For BF, so 60 minus 8.4, then plus I think 0 na siya dito guys, then times the distribution factor, negative 0.45. Okay, so negative 23.2. So that is all for joint B guys. How about for C? No, for C, again sa natin negative 0.924. So COM of CB, then plus COM of CD, then COM of CE. So sila. Then times the distribution factor. So 0.924 na guys. Then how about this? Same lang yapon na guys, no? So COM of all those members connected at C, then times the distribution factor, negative 0.36. Also here, no? Same na siya guys. Ang mag-vary lang is the distribution factor. Okay? So sa joint E and F is 0 lang gapon na siya guys, no? Because COM na siya, no? Ang may tabo dira is COM times the distribution factor. Same po na dira guys. COM times distribution factor, so 0. So kanina lock na siya guys, ha. Wala na siya. Okay, so that is for the distributed end moments. Then next is COM, no, to complete the second cycle. So kani 0 na siya, di ka na siya dito guys. So kana dito, di ka na siya dito. Then kani, so BC, no, gikan na siya 1/2 dere. Then kani, gikan na siya dere 1/2, no, pasa 1/2. Then the same with this, no, pasa dere siya, gikan na siya dere 0, imaginary. Then for CE, nanay pasa dito 1/2, then 0 pa pasa dito. The same here. Nakanay 1/2 dito pasa, then 0 pasa. Okay? So that is a cycle na. So after getting the CUM of all the joints, so what we will evaluate is joint B and C. So tanaw na to ang CUM guys sa joint B and C. Okay, so kita na to dali 0, then 0.426, then 0. Okay, so napa guys na nagapon 0.426 again. Take note of our tolerance, which is positive and negative 0.001. Okay, so napatay unbalanced moment guys na 0.462 at joint B. How about for joint C? Sa joint C is negative 5.627, then 0, 0. Okay, napata guys, negative 5.676. Okay, non-balance moment. So sa E and F, so wala kay tayo problema dara, no? Kaya expect kita na naga na moment dara since this is a fixed support, no? So we still have those unbalanced moments. So proceed to the third cycle. Okay, so third cycle guys, so same na gapon. So we'll get the DM. So kana asa ni nakuha negative 0.152. So dito gapon na sa CUM, no? CUM from the second cycle. Okay, so kato siya from the second cycle. Then times the distribution factor. Also here, no? Times the distribution factor. Then kanipod. I think kanina guys. So kanay. So dito gapon na CUM from the second cycle. Then times the distribution factor. Okay, that is at joint B. So joint C guys, so same lang gapon, CUM of the second cycle of all the members connected there times the distribution factor. Then same gapon na guys, nato lang gapon. And also here. Okay. Then 0, 0 gapon na dali guys, na sa kuan sa BF. Then sis lang. Then get the CUM, no? CUM guys. So kani 0 pasa kay gikan na dito, no? Sa A. So kani pasa dito gikan sa D. So 1.192 divide 2, so mao ning na 0.596. Then kani pasa pa dito 1/2. Then kana 0 dito. Then 2.441 pasa diri 1/2, then 0. Then for BF, so negative 0.208 pasa diri 1/2, then 0 pa gikan na diri sa F. Okay, so after carry over moments, again evaluate joint B and C. So tanawon mo yung mga CUM na pod guys. So at third cycle kita to the 0. Okay, so napay 0.596 na. And tanaw pa naman diri pwede pod kani. So 0 man gyapon guys. So mo na ni 0.596 sa C guys. Natay negative 0.51. Expect man kita diri na usually 0 ni diri. Okay, so 0 then 0. Okay, so napa jud guys. So proceed to the fourth cycle. Okay, so DM for the fourth cycle kani. So para nakuha ni gikan sa gikan dito sa CUM, no? CUM sa third cycle of all joints connected. Then times multiplication factor, the same po na dali guys, and the same po na dali. Ana. Okay? For the fourth cycle. Then for C also, gikan na dali sa negative 0.51 guys, then 0, 0. Okay? Times multiplication factor. Then kanipad. Okay, so gikan na siya dito. So multiplication factor lang nagbari guys. Okay, then negative 0.022. Then sa kani 0 again, no? 0 lang gyapon. So next is UM. So gikan na diri. Then pasa na pod 1/2. Then kani pasa na pod dito 1/2. Then kani pod pasa pod diri. Gikan 0 dito. Then kani pasanay gapon katong 0.022 pasa diri. Then kana pod pasa 1/2. So after pasa, then evaluate the CUM, no, at the fourth cycle. So 0.0, 0.05, then we have the 0 here. Okay, so napagyapon guys 0.005. Then sa C, nagyapon negative 0.07, no? So expect 0 manggapon na nalay guys sa C. Kani. Okay, so hapit na gyud, no? So napamay 0.005 sa B, then napay negative 0.07 sa C. So proceed to the fifth cycle. So kani dito gapon na guys ikan sa COM times DF kana, then also kani. Okay. So kani 0.014, then kato add tanan kana pod kana. Okay, COM from the fourth cycle times the modification factor. Then 0, then again here 0. So pasa para magka COM, then kani pasa na pod, then kani pasa dito. Okay, so pasanay na pod guys 1/2. Kana na pasa dito, then kani pasa dito. Kani pod pasa dito. Then after, mag-carry over, then evaluate the COM at joint BNC again. So, we have here 0. Okay, so naapay 0.007. So, gamay na lang guys, na. Because 0 man na siya diri. Sa C, though sa C, marag negative 0.001 na siya, no? Sa C. So, marag, ang C, okay na siya, pero ayaw sa ilak, no? Since we still have this unbalanced moment here sa B. So makaapekto gyapon na siya sa result later, no? Sa kuan sa C, no? Mga moment na nakakabit sa C. No? So ayaw sa undang. So ayaw sa ilak ang C hantod sa di po ka maman sa B, no? Because this unbalanced moment here sa B, no, will affect the results later, no? Labi na dali sa MCB, dali sa MCD, and sa MCE, no? Kana sila makaapekto pa na siya. So ayaw sa ilak ang C, no? Kay wala pa nahuman sa B. So maybe this will be our last cycle guys, no? Sa cycle 6. So DM for cycle 6. So kato CUM sa 5 0.10 add ni mo ni kato. Then times the DF also here, no? Kana DF. Then kanipod guys. So add the CUM, no, of cycle 5 times DF. How about for C? Also, approaching 0 na siya guys, na. Then also here, approaching 0 na gid siya. So kanapit na. Okay? So lastly, CUM, so pasa 0, then kani pasa dara. Kana pasa dito. Kani 0, then pasa na pod guys, pasa, then pasa. Okay? So imo nang i-evaluate na ang CUM sa B karon. So kita na to 0 0 0 na guys. Okay? So wala na tayo unbalanced moment sa joint B. How about for joint C? So joint C is negative 0.001, then 0, then 0. Okay. So joint B and C are now 0 na. So 0 na ang ilahang mga unbalanced moment. So we will have to lock, no? So i-lock na natanan guys. So I think parang ako'y mali na napita. Okay, so ito na i-lock sila guys. Okay, so ito na i-lock. Just draw a double line, no? Double line. So ito na i-lock guys. Ito i-lock. Then lock. Okay, so pasabot guys, pag once mo lang ilak, then the cycle is over, then wala na, dili na magpasa, no? So mga dili na mag carry over na. So since wala namang kay pasa po, okay, wala naman yan balance moment. Okay, so ato na siyang ilak. Then after nato ilak, then add all the moments, no, from FEM padulong sa tanan cycle. So expect na nato lang AB guys na 0 gina siya. Then for BA, so from 120 to 0, no, add na tanan. So ato nakuha guys is positive 149.419 ang moment for BA. So for BC, so add na po na tanan guys, no, from negative 80 to 0. So nakuha na to is negative 107.717. Okay. So next for BF, so add na po na tanan, no, from 0 to dito, no, sa pinaka-last. Then makuha na to is negative 41.702. Okay, so in order to check guys if tama bagid na ato ang gibuhat, no, kailangan ang moment dara is 0, no. So add na to na moment at BA plus moment sa BC plus moment sa BF. So kailangan 0. Okay? So our result is 0 guys. So therefore, so tama ta na. Pero napay isa, no? Try to counter check sa C. No, sa C na pa ta guys. So for CB, no, moment for CB. So add na tanan. Then natin 55 na positive 55.146. Then for CD, so add niya po na siya tanan guys, no? From 0 to all the cycles. So we have negative 25.130. Then for CE, kani, na from 0 to the last point or last cycle. So negative 30.017. So ato ang try add guys. So add na to si MCB plus MCD then plus MCE. Okay. Uy, ano ni? Value. Ay, mali guys. Ito na dapat. Okay, so negative 0.001. So which is okay gapa na siya guys, na? Because that is within our tolerance. So tama na. Tama ta sa mga moments na ta. So sa moment DC, expected 0. Okay, dali na lang guys sa mga fixed supports. So same na gapa, no? Add lang na tanan, no? From 0 to the end. Then kana pa dali. Okay. So negative 20.851, no, for moment FB. Negative 15.008 for moment EC. Okay. So these are our end moments guys, no? Okay, so kana sila ato mga end moments. So after getting all the end moments, then you can get the reactions now.